Hi students, welcome to physics class. Today we will discuss about electric field intensity at a point on equatorial line of electric dipole. Let us understand some basic concepts. Source charge. The charge which is responsible for the electric field is called as source charge. Next one is test charge. The test charge is one which is used to calculate the intensity of electric field at a given point. And intensity of electric field is calculated by using the formula E is equal to 1 by 4 pi epsilon naught Q by R square. The intensity of electric field is directly proportional to the magnitude of source charge and inversely proportional to square of the distance from the source charge to a point where we have to calculate the electric field intensity. The direction of electric field is from O to P if the source charge is positive and P to O if the source charge is negative. Electric dipole. Electric dipole is a system in which two equal and opposite charges are separated by a distance 2a. Next one is equatorial line. Equatorial line is a point which passes through the midpoint of electric dipole and splits the electric dipole into two equal halves. Let us consider an electric dipole in which at point A there is a negative charge and at point B there is a positive charge which is separated by a distance of 2a. Here O is the midpoint, so AO is A and OB is also A. Let us consider a point P on equatorial line at which a positive test charge is placed. The distance from O to P is R. And draw a line from P to B. As it forms a right angle triangle, we know that the hypotenuse is equal to square root of side square plus side square, that is A square plus R square. Similarly, draw the line P to A. Here PA is also the hypotenuse in a right angle triangle POA. So hypotenuse can be written as square root of side square plus side square. Because at point P there exists a positive test charge and at point B there exists a positive source charge, there exists an electric field which is directed toward B to P. The direction of electric field is from B to P because the source charge is positive. Let us denote this electric field as E1. Similarly, at P there is a positive test charge and at A there is a negative charge. The negative charge is a source charge. Therefore, the direction of electric field is towards the negative charge. Let us say the intensity of electric field is E2. Hence, at P there exists an electric fields E1 and E2. Their resultant is E. Now let us resolve the electric field E1 into two perpendicular components, that is E1 sin theta and E1 cos theta. Here theta is the angle between E1 and resultant electric field E. Similarly, resolve this electric field intensity vector E2 into two perpendicular components, that is E2 sin theta and E2 cos theta. Now let us write down the electric field intensity E1 by using the formula E is equal to 1 by 4 pi epsilon naught Q by R square. We get 1 by 4 pi epsilon naught q by r square. Here r is the distance from P to B. That is equal to 1 by 4 pi epsilon naught q divided by square root of a square plus r square whole square. That is equal to 1 by 4 pi epsilon naught q divided by a square plus r square. This is the electric field even at P. Similarly, electric field E2 at P can be calculated again by using this formula 1 by 4 pi epsilon naught q by r square. 1 by 4 pi epsilon naught q by r square is the distance from P to A. So PA whole square, that is equal to 1 by 4 pi epsilon naught q divided by PA means square root of a square plus r square whole square, that is equal to 1 by 4 pi epsilon naught q divided by a square plus r square. This is equation number 1 and this is equation number 2. From 1 and 2, it is clear that E1 is equal to E2. Let us say it is equal to E, which is equal to 1 by 4 pi epsilon naught q divided by a square plus r square. Now the intensity of electric field at equatorial line is equal to E1 cos theta plus E2 cos theta, because E1 sin theta and E2 sin theta are acting in opposite direction to each other, and E1 is equal to E2, which is equal to E, that is 1 by 4 pi epsilon naught q by a square plus r square. So these two vectors, these two components are equal and they are acting in opposite direction, so they can cancel out. So the equatorial line, electric field along the equatorial line is equal to E1 cos theta plus E2 cos theta. We know E1 is equal to E2, so we can write this as 2E cos theta. Here theta is the angle between E1 and E. This theta can also be equal here, that is equal to 2 into 1 by 4 pi epsilon naught q by a square plus r square, and here theta can be written as theta is equal to cos theta is equal to adjacent side by hypotenuse. Here adjacent side is a by hypotenuse is square root of a square plus r square. Therefore that is equal to 2q into a divided by 4 pi epsilon naught a square plus r square. The square root of a square plus r square can be written as a square plus r square whole to the power of 1 by. Here bases are equal, therefore the powers can be added here. 2a into q divided by 4 pi epsilon naught a square plus r square whole to the power of 3 by 2. Here 2a into q is equal to electric dipole moment. So equatorial line, along the equatorial line, electric field intensity is given by P divided by 4 pi epsilon naught into a square plus r square whole to the power of 3 by 2. Special case, as r is very much greater than a, then A can be approximately equal to 0. Now we can write this equation as E equatorial is equal to P divided by 4 pi epsilon naught. Here A square is approximately equal to 0 square, which is equal to 0, and R square whole to the power of 3 by 2. Here 2 gets cancelled. Therefore E equatorial is equal to P divided by 4 pi epsilon naught into R cube.